So we've counted up the available valence electrons already. We see that we have 9 electron pairs. The second step is to connect up the outside and the center atoms and to complete the octet of the outside atoms. So each of the oxygen atoms will require 3 lone pairs to complete their octet. Completing the octet of the outside atoms uses up 8 of our 9 electron pairs. Now we want to complete the octet on the center atom. We can place the one remaining pair on sulfur as a lone pair, but we see that it's still electron deficient. Currently it has 2, 4, 6 valence electrons. It's electron deficient by 1 electron pair. So we're going to cause 1 lone pair on one of the oxygen atoms to convert to a bonding pair, and then we want to rewrite the entire structure. Now, if we look at the sulfur atom, we see that we have 2, 4, 6, 8 valence electrons. We gain 1 electron pair towards the octet in sulfur by converting one of those lone pairs on oxygen to a bonding pair. Now we could have formed a double bond with the left-hand oxygen atom. This is a second resonance structure. These resonance structures differ only in the placement of electrons. In this resonance structure, we see the double bond between the sulfur and the right-handed oxygen, and here's a double bond between the sulfur and the left-handed oxygen. And in each case, we see oxygen has 8 valence electrons, and sulfur also follows the octet rule. So this is a valid Lewis dot structure.